Okay, so I'm going to walk you through the fossils experiment. It's pretty straightforward. Actually, it's so straightforward that I'm a little disappointed by it. It's pretty much identical to the experiment I do with my elementary ed majors. So, uh, um, I'm going to talk to Science Interactive about why that's in a 200 level, well, a second level course. It's not 200 level, but it's a second level course. So what you're going to need is you have this sack right here with all these different powders in it. It's labeled fossils. You're going to need this guy. You're going to need your styrofoam cups. You're going to need the graduated cylinder, and you're going to need water. And this gets messy, so you're going to want to do this somewhere that you can have, it's not like super, super messy, but you're going to want to do it somewhere that you're not having to deal with, like, don't do it on top of your homework or your laptop. Not a great idea. You probably want to do it somewhere where there's a sink and paper towels and easy cleanup. So let's go ahead. I'm going to share my screen. So, and I'm just doing this in the second half of the Zoom. If nobody shows up, this is what I do is I just walk through the lab. You guys are welcome to show up at these hours. You're welcome to make other appointments. It seems like people are trucking through. Those who have the lab kits now, people are kind of making short work of the lab, so that's good. So this is actually one of the easier labs. This is not the stratigraphy lab, which I know was very challenging for a lot of students. So in this one, what you're going to do in this first part, so there's two experiments here. There's fossil processes and fossil identification. So in this first part, um, you're going to make a fossil. And if anybody's ever made a fossil with, for example, in grade school, which is where you often see an experiment like this, it's the same thing. The one thing that makes this a little bit different is that we have, in our case here, um, we have we have the added complexity of looking at the different substrates. Now, substrate in science is just a very fancy schmancy way of saying different materials. So you're going to have sand, you're going to have your dirt, you're going to have your soil, and you're going to choose one of your clays is going down because you're not going to want to reuse this clay after it gets coated with plaster of Paris. So put it back in the container just in case you need some spare, but it's not going to be nearly as nice. And you're going to go ahead and you're going to make a fossil. So what you're going to do is you're going to get your styrofoam cups out. And you're going to want to label each one with what sediment you have in it. So you have 3 sediments. You have the clay. This really represents clay, geologic clay. Like we see that makes things like a shale. You then have sand, what would turn into a sandstone. And then you have soil. Big hint, we don't see a whole lot of soil. It's called a paleosol. We don't see a whole lot of soils turning into rocks. So that should be a pro tip. So what you're going to do is you're going to take First, you're going to take I'm going to make myself big because we don't need the screen right now. You're going to take your little shell. Everybody should have a shell. My shell looks like this. Everyone's shell is a good shell. And you're going to take measurements and you're going to record them. So you take your ruler and you have measurements. I take my measurements in several directions. And I record that in the data table. I then take my first sediment. It's a clay. I don't want to use up my clay because they're not going to give me more clay. I'll get my own clay. So you're going to take your clay and you're going to make a layer in the bottom of your cup. A little bit like that. Boop. And then you're going to take your shell that's going to become your fossil and you're going to push it down. This is toughest with the clay. You're going to push it down into the bottom of it. You see? And you can see that there's an impression of a shell in there, right? And you're going to do the same thing with sand, and you're going to do the same thing with soil. You just push it in, make an impression, take it out. Go to the next one, push it in, take it out. The next step, and it gives you directions on how to do that, you're going to mix up your plaster of Paris. Do not mix your plaster of Paris in your graduated cylinder. You're going to need your graduated cylinder later on, and if you have plaster of Paris, it's never going to clean right. It's just not. Trust me, I've made that mistake. So once you get plaster of Paris on something, it does not want to clean right. So it's not worth your time. Just use a separate container like it gives you directions for. So, but use this to measure out and do try to be precise with the measurements. It's going to make your life easier. Okay. You don't want it to set so quickly. You have concrete in about 5 seconds and you can't pour it. And now you're stuck and you don't have any plaster of Paris. You also don't want to make it so liquidy, it takes forever to dry. So the ratios they have in the lab, be careful, follow them. Now let's suppose you have an accident and you don't have plaster of Paris anymore. Well, what you can do is just go down to the hardware store because plaster of Paris is very cheap and you can get small quantities at the hardware store. Don't go to Hobby Lobby, they overcharge. But go to the hardware store and get some plaster of Paris and you'll probably have way more than you'll ever use. Take casts of your foot, whatever you feel like. But yeah, you can run down and get it there. Yeah, fill your cup. I do recommend, once again, in case there's an oops, use about half of your bag of soil, half of your bag of sand. Then you'll have some in reserve just in case things go sideways. Because you don't need all of this in this cup to do this experiment. Okay, so it hardens up. Then you make some deductions about how substrate influences fossil formation. Let's go ahead and take a look at the second part of the lab. Pretty straightforward. Fossil identification. That is involving not this guy. This guy is done. We can put him to bed. Good night, little shell. He's a modern specimen. He is not a fossil. This guy is not a fossil. Okay. Why? It's not because it isn't made out of rock. It's because it's modern. It's not old enough. Okay. So, really, we consider it a fossil if it's older than the last glacial maximum. So we're talking about 12,000 years ago, 13,000 years ago. So if it's older than that, we can call it a fossil. If it's younger than that, we don't call it a fossil. Okay, whether or not it's a rock. Let's take a look at our bags. We have 3 little fossils here. You're going to take your sheet of graph paper. They do provide the graph paper. And you're going to sketch these. And take your time on this. This component I have in my class too. You learn a lot by drawing. It may be helpful for a lot of you. Pro tip, to take a picture with your cell phone, blow it up, and then draw from the picture on your cell phone. Because I'll tell you what, when I do this in actuality, like when I have done this as part of fossil description in a paleontological laboratory where I was doing work, I wasn't a student, well, I was a student, but I was doing work for a professor. We have a special kind of magnifying, we have a special kind of, my brain is not, I got better, but I'm still apparently not 100%. They use it in, not a telescope, a microscope. Excellent. We use special microscopes. And there's actually a type of microscope. It's really cool. They used it for a long time before they had cell phones, where it will actually take it and blow it up as a picture next to you. So you can actually outline it as you're drawing. It's very cool. Cool. I've actually used one of those. I mean, they're very old school. They were out of date by the time I was using them because there's already cell phone cameras. But drawing it out really helps your brain, really helps you see things. So once again, I do recommend trying, like, putting it on a different colored surface from it, taking a picture with your cell phone, blowing it up with your cell phone, and then taking a drawing from that, because I find that most people are not very good at perspective. They're just not. I know I'm not. I'm not a great perspective person. So you're gonna add your drawing, and like this table, like so many tables in this, I'm pretty upset about. I'm really upset that there was no mineral table in the last lab. I've heard the chemistry kit is very good, but this is not. I'm somewhat disappointed. Um, this is not a great chart. Okay, what I do recommend is, if you think, for example, let's suppose you notice that fossil A is similar to, you say, oh, it could be horn shaped or it could be coiled. Well, then Google rugose coral and ammonite. Google that fossil name and take a look at some of those pictures. That's an excellent way. That's a terrible way to identify rocks, but a fantastic way to identify fossils. Just because rocks, there's so many other things, rocks can look very superficially similar and they're not similar. That's not true of fossils. You know, the images on Wikipedia of these things are actually very useful for identifying them. So, so yeah, this is not terribly useful. If you need an additional chart, I do have additional charts. I can't upload them, just email me. And then a lot of these questions down here are attached back at the exploration. Do go over the exploration every single time, because a lot of the subsequent questions down here are based on that exploration. Okay, so so that's it. It's a pretty straightforward lab. Like I said, I actually don't consider it at the level of this class. It's something I would do with my GEO 110s. Not necessarily I would do in the classroom with my GEO 132s. Most of you are science majors, although I know a few of you are not. But I really have confidence that you can make a shell. If you have trouble with the identification, once again, I'm always here. I have a different additional charts, but Googling those fossil names can be a big, big help for you to get the images that you want. And if you have any questions, please reach out.